All right, so today we're going for our first Elegoo programming workshops. We did have a kind of how to program the Elegoo a couple of weeks ago now. This one will be the first one that's approaching, I guess, a practical aspect, so actually doing something. And it'll be about essentially driving the car around, so looking at those DC motors to make it go forward, backwards, and turn. And the presenter today is Roxy, and she is an alumni from 4252, which is in Markham, maybe, I think. Yes, good. I think there are actually a few of them are joining us possibly on this endeavor. And she's currently a mentor for Dave and a computer science at the University of Waterloo. So without further introduction, I will let her take the reins and go for it.
All right, thank you, Eric. I'm just going to share my screen with the presentation. Oh my goodness, so many tabs open. Okay, actually, I think I'm going to share my whole desktop just so it's easier. All right, can you guys see my screen?
Yep.
All right, great. So let me just make this big and click present. Oh, I might want to present from the beginning. That would be a good idea. Okay, so as Eric said, this workshop is on making the car move and just in very, very simplistic terms, controlling the Elegoo's DC motors. And so it would be a good idea if you guys can follow along, and I'll let you guys know what you need to follow along. But first I'm going to go through what we're going to be doing in this workshop. So we're going to cover what you guys need. I already said this. And then the next thing we're going to cover is the L298N motor driver. If you don't know what that is completely fine. That's why we're going to cover it. The next thing we're going to cover is moving the wheels. And then after that, we're going to cover moving the car, which seems like it's the same thing, but it is slightly different, and you'll see how. And then the last concept we're going to cover is speed control. And then we will go for a Q&A, and I will answer any questions. So just before I start, I think, so I'm going to stop at the end for a Q&A, and I'll try to intermittently stop if you guys have questions and ask, hey, does anyone have any questions? But I might forget to do that. So I think I can see if you guys like raise your hands or something, or ask a question in the chat. If not, Eric can help me out there. And so I'm just gonna go ahead. So first, what do you need? So you need the robot, you need your robot, you need it assembled, and you also need the I think I have it here. You need the ESP01 module. You can see it right here, to connect and to be able to upload code. Now, in this workshop, I've tried it right before, and for it's still a little bit finicky, the IDE that we have to upload code. So I'm going to be using mine is unplugged, and I'm going to be using a USB-B port to plug it directly into my Arduino board to upload code. You guys can also do that if you have a USB-B. But I mean, obviously you guys might not be prepared. So probably the best way to do it, if you can, is the ESP module. I just didn't have time to debug why it's not why it's being finicky. So I'm going to go the old-fashioned way. All right, so we need the robot, and you should have some basics of Arduino, the tutorials that we put up, Arduino Basics 01 to 03, and Intro to C++ 01 to 03. So we're going to be using some of the concepts that we learned there. We're not going to be using all of them, and I'll try to cover the bigger concepts. I'll try to give like a quick recap, and if you have any questions, you can always ask, but keep in mind that these questions might be answered in one of these tutorials. So if you haven't seen them, it might be a good idea to watch those first. If not, you might just have a little bit of a hard time right now, but you can always go back and watch them later. You also need to have watched Eric's presentation on how to program the robot, and that is mostly because of to know how to upload code. Again, if you're going the old-fashioned way like me out of necessity with the USB-B cable, then you're fine. But if you want to follow along, you do need to have configured you need to have configured this module. I'll show it again, the one that looks like this. If you haven't, that's okay, just follow along, and you can't really do it now because it does take some time. So, it's okay. You can always come back to this video later once you've done it. And then the last thing we're going to use is the Arduino, when I planned this presentation, we were going to use the Arduino app IDE. Again, I'm going to be using the Arduino IDE because for some reason that doesn't work for me right now. All right. Anyone have any questions? I'm not seeing any questions, so I'm gonna move on right ahead. So first we're gonna go over the L298N motor driver. And so if you have your robot in front of you, I would like you to, I'm not sure if you can see my robot. The top of the chassis has 6 screws that's connecting it to the bottom, and I'd like you to unscrew it if you can, just so you can actually see with your own eyes what's going on. If not, I have this handy dandy diagram up here and we can look at it together. So I've already unscrewed my chassis, so I'm just gonna lift it out. You guys aren't gonna be able to see what I'm seeing just because there's really no way to film this, but you can look at this right here. You guys can see my mouse, right? The mouse moving around. Yep, okay, cool. So if you want to detach the top of your chassis to look at the L298N motor driver that's attached to the bottom chassis, you will see something that looks like this. So the way that the purpose of this this module is, it's a motor driver, so it takes power from the Arduino board, which takes power from the battery, and then controls the DC motors. So if you want to look at the top of your, let me see if I can, I don't think I can. So if you want to look at the top of your robot, your I/O expansion board is split up into rectangles that each have some wires coming out of them. And so, for example, number 1 is line tracking, number 2 is servo, and this is just the way that they've organized these modules. And so if you want to look at number 3, you can see that there's the L298N power module. You can see that there's a red wire and a black wire going coming from the Arduino board, and it goes underneath into the L298N board here. Oh, whoops. And it comes here. So here you have your power and your ground, and that's what supplies power and ground to this motor driver. But that doesn't really give us a whole lot to work with. We don't want to just say, okay, all motors are either on or all motors are either off. So in order to actually control these motors, we have these. We have on the top of your I/O expansion board, you can see the section number 4, L298N control. And it has 6 wires coming out of it that have finer controls for these motors. Now, you might be wondering why there are 6 wires and there are 4 motors. So if you see your own motor driver here, these wires are labeled. I couldn't get them to fit because the label would be really small. I couldn't get them to fit on the slide. But this one is labeled in 1, in 2, in 3, in 4. And this input comes from the Arduino board and goes to motor 1, motor 2, motor 3, motor 4. So you might be thinking, what's with these extra 2 wires? And so I will cover that right now. So first we're going to go over how we move the wheels and what tank drive is. So tank drive is, if you want to think of a tank, it's essentially you drive your robot the way a tank works. The left side, the left wheels, the left side of the robot moves in the same direction, and the right side of the robot moves in the same direction. So you don't want to always be controlling 4 individual wheels. Conceptually, you want to think of it as left side and right side. So tank drive is a way to control a robot's motion by manipulating 2 parallel forces. And we use it in our FRC robots. And again, although there are 4 motors, we will make it so we will move both the left motors in the same way and both the right motors in the same way. And so the reason for those 2 extra inputs is that the hardware lends itself to this style of control. And we'll see how. So this ENA input decides whether or not we're going to listen to these two. And this ENB input decides whether or not we're going to listen to these two. So essentially, it's an on and off switch. So this ENA input is an on and off switch for the right side, and this ENB input is an on or off switch for the left side. And we'll see how we do that programmatically. Does anyone have any questions here? This might be a little bit. No? Cool. Okay. All right, so we went through tank drive, and we're going to see how this tank drive is used. So I'm just going to reassemble my robot. Actually, I'll reassemble my robot in a second. So we're going to go through how the L298N motor driver does this. And it does this by taking the inputs ENB, IN3, and IN4, and we want to go back and see all those, just so we remember. This is ENB, IN3, IN4. So this corresponds to motor 3, motor 4, and this is ENB. So what does the L298N motor driver do with these inputs? What it does is it reads the input and it performs an action. So the left wheels do something based on these three inputs. And so the way that I said that this is like an on and off switch, if ENB is off, then that means no matter what IN3 or IN4 are, your wheels are going to stop, the motors stop. So basically ENB says, okay, we're not, if I'm off, don't listen to what IN3 or IN4 say. It doesn't matter, we're going to stop regardless. So you can imagine, and we'll go into it, it'll prove to be even more important later, but you can imagine that this is nice that you don't have to do two things every time. Instead of turning IN3 and IN4 off, you can just say ENB off. And that works really well. It's really helpful conceptually when you think of tank drive, because you don't want to say, okay, I want to move this right wheel like this, and this, or this front wheel like this, and this rear wheel like this. I just want to say ENB stop, and that side of the car will stop. And so next, we have what happens when ENB is on. And we have, so when ENB is on and IN3 and IN4 are off, then the left wheels are off. So this is the front wheel and the right wheel, front wheel and the rear wheel. This is both on the left side. The left side stops. And so you can see we have more than one way to stop the left side, but we're going to use this way, and we'll see. Well, I already kind of explained why, but we'll see even more reasons why we want to control it like this. Okay, and then when ENB is on and IN3 is off and IN4 is on, the left side moves forward. When ENB is on, IN3 is on, IN4 is off, left side moves backward. When all three are on, the left side stops. And so, oh shoot, what was I gonna say? I was just gonna say something quite important that I forgot what it was. Maybe it will come back to me. Oh, yes. So I was gonna say that this like logic is in the L298N motor driver. So it takes these three inputs and does this action with the left side. And we'll go over the right side as well. This is just using the left side as an example. And so we're gonna program this behavior. We're gonna program this behavior on our robot, and just while I'm screwing the chassis back on, are there any questions? Any questions so far? If you guys want to get your coding set up while I do this, it'll just take a second. But if you guys want to get your coding set up while I do this, that might also help. Okay, well, I guess.
I'm not 100% sure on this, but I think if your IN3 and IN4 are 1, the motors will brake, whereas if there's 0, the motors will coast. So they're both off, but one of them is kind of off and let it glide, and the other one's off and put the brakes on, I think.
Oh, I see.
I think that's the difference between 0, 0 and 1, 1.
All right, well, okay, well, there you have it, folks. I didn't go into that in this tutorial, but that's a good tidbit to know. And well, the reason I chose, oh, no. The reason I chose this way is for speed control, which we'll see later, so that we can, like, again, act as though it's tank drive, and for both sides, we can increase and decrease the speed rather than having to do them independently. Okay, did anyone have a question? I thought I saw like a check mark or something. Is that?
Might have been a thumbs up or something.
Okay, cool. So I got everything done. So now let's go to programming. Oh, it likes to switch back and forth. Okay, you guys can still see my screen, right?
Yep.
All right. So that's not the right one. I want it to be the blank one. You guys can't see my cheat sheets. Okay, so we're going to make play with the left side. So I'm gonna say what we're gonna do here. What we want to do is first move. We want to go forward, left wheels, brake, forward. Sorry, backward left wheels.
Could you do Control plus a couple of times just to make the text bigger? Imagine this is a little small on Chromebooks.
Yeah. I'm sorry about that. Can you guys see now? Okay, great. Okay, so this is what we want to achieve. We want to do a simple sequence and we want to see our wheels moving. So I kind of already have a cheat in here. I have this, I wrote it down for myself. So we've covered this before, I believe, in the Arduino tutorials, the idea of a global variable. So this is useful because if you look at what I was talking about previously, if you look at the IO expansion board on the top, you can see that coming from the Arduino doesn't know that one wire is ENB. That's for the motor driver to know. The Arduino doesn't know. The Arduino just knows this is output port 5. And so for our purposes, when we want to program the bot, we don't want to think every time, okay, what's output port 5? What does that do? We can just label it ENB, or in the case of 7, we can label it N4, 8 is N3, and so on. And so that way it's easier for readability. And also this doesn't apply for us now because we're not going to go changing around these values. But if we were to change them, that way we could just change if we wanted to change this, we wouldn't have to go through the whole program and look for, okay, where did I put 5? Now I want to put 11. We can just change the value here and the label will stay the same. So I think we've gone over that. I just went over it again briefly, and I kind of did the dirty work of figuring out which one goes to which. So you guys don't have to worry about that. You guys can just write this down. Okay, so first we want to set up, and what we're going to do first is we're going to say serial.begin. You guys, by the way, I don't know if I said it, if you guys want to follow along, you guys should probably do that. If not, that's okay too. You guys can just follow along with me. So first we're going to do serial begin 9600, and we've covered this in previous Arduino tutorials. Unfortunately, it's not really applicable in my case because when the code is actually running on the bot, it's not plugged into any serial monitor. I just upload the code and then run the car. So it's unfortunately not like you can't see it in my case, but it would be useful if you're actually connected to the port throughout. Okay. So the next thing we're going to do is we're going to set up pin mode ENB output, and then copying and pasting is a really, really useful tool. I'm sure you guys know in a programmer's arsenal, but it's kind of a double-edged sword, at least for me, because I always forget to change what I copied. So, exercise that tool with caution, as I'm sure you'll see throughout this tutorial. I do not really exercise that tool with caution. It's a habit I can't seem to break. Anyway, so we've set it up. And so something that might be confusing for you guys if you guys haven't already realized, this is called in3, but we labeled it as output. The reason that we've done this is because it's called in3 on the L290N motor driver. So because it is input to the motor driver. But for the Arduino board, it's output. We're outputting something to this pin that is then taken in by the L298N motor driver. So this is just a naming convention. We could technically name it anything, but just to have cohesion between the hardware and the software and the way we program, we want to label it the same thing. So that's why we've done this. It is output for the Arduino board, but it's input for the motor driver. Okay, so forward left wheels. How do we do that? We're going to look at our, oh no, answers. We're going to look at our truth table, and we're just going to do what it tells us to do. Oh, that's not what we want to do. Okay, we're just going to do what it tells us to do. So forward left wheels, how do we do that? So we're going to say, first, what we're going to do is we're going to say digital right ENB high, which corresponds to this one value here, digital right ENB high. And then we're going to say, we're just going to go right across the row. We're going to say digital right IN3 low. And I'm just going to do a sneaky copy paste move here. I do not want to write it out. And arguably that was the same amount of effort as just writing it out all over again, but you know. And then we want that to happen for 1 second just so we can see it happen. So we're going to say delay 1,000. Okay, and maybe this would be a good time to actually see that it worked. So what I'm going to do is I'm going to plug, first I'm going to verify. I'm going to make sure, that it's okay. Hopefully it's all right. Shouldn't be.
There's a question that's, is indentation important for this code?
Indentation is important for you to read this code. As long as you have these semicolons between your statements, you're okay, and like your brackets and everything. It's not important in that it's like grammatically correct, but it makes it a pain to read if you put everything on one line. I like to make everything spread out, and it might not be relevant now, but like as you write bigger and bigger programs, they get harder and harder to read if you don't indent properly. Okay, so I'm just gonna plug it in because it worked. Upload, and hurrah, done uploading. Okay, so now I'm gonna turn my robot on, and hopefully it does what I promised it will. Okay, it should be these wheels. So you can't see because it's moving too fast, but you'll have to take my word for it. They are moving forward. And we're just going to write the rest of these, and I'm gonna go a little bit faster. I'm not gonna talk through them just because it's just copying from the chart, but I would advise you guys to go along with me, and we'll go from there.
And if I can offer a pro tip that doesn't totally matter here, but just as a matter of habit, if you have an enable line on a control system like this, often it's better to enable it at the end. So you would set your ins, then you would enable it, just so you don't have the funny situation if you're actually controlling a tractor and you enable it first, it'll go in whatever direction it was set for before, and
Yes.
then it will then it'll figure out that you've changed direction. So this is here, it really won't matter. It's such a small thing. But at that job I was talking about earlier, we had a glitch on an input on reset, and it made the shovel go up about 6 inches on this like microsecond glitch. So it can be dangerous in real life.
Yeah, that is a good tip. I will keep that. I will add that to what we're doing, and then here we're going to do the same thing. All right. Okay, so here what we've done is we've created a sequence where the wheels go forward for a second, brake, go backward for a second, and then brake. And so we're gonna check that and upload it again. Maybe I don't have to check it every time. I think I'll just upload from now on. Okay. Just in the interest of saving time, because these are fairly non-aggressive programs. Okay, So I'm gonna unplug it and then turn it on, and you guys can see okay, and it'll just do that forever. Great. So I don't like the way that this looks at all. I don't like the way that everything, the loop function is already so long, and I'm repeating these. And so if you remember the Intro to C++ workshop, the idea of functions. So a function is used when you have repeated pieces of code, or pieces of code are really long, or it becomes difficult to read with it and you want to abstract away the problem. You don't want to be like seeing these calculations all the time because it takes away from what you're actually trying to do. I know that this is how you go, you make the left wheels go backward. So I'm just going to put that somewhere else in a function, and then I will call it so that I don't have to look at it all the time. And we'll see how that is done. So what we're going to do is we're going to create a function that returns nothing. So it's a void function. And we're going to say break left wheels. We're going to give it an integer parameter pause. And we're going to take this and put it right here. And I'm going to write to our serial port, even though for me it makes no difference. For you guys, it might help. Serial write, break left wheels. And we can remove this. We don't have to put this now here. What's nice about this is we also don't have to, well, we don't have to put the comment regardless, because the comments don't affect the running of your program, but it's important for you to read it. Now we can see we don't have to put the comment, because if we just say break left wheels, everyone can tell, oh, that's what we're trying to do here. We're making the left wheels break. Okay, so right here, and we can try that as well.
You're missing a double quote on the third line from the bottom.
Oh, I did that last time when I prepped this as well. Okay, so I'm gonna compile it just to see what happens when I do that. Yeah, I did it on purpose. Don't worry, it's on purpose. So you can see here that I made a syntax error. I missed this double quote right here, and you can see that it won't compile for me. So I'm going to compile it now.
And then you'll want to copy your pause down to your delay function too.
Yes. Okay. Oh, yes, and I forgot to talk about a very important part. Sorry. So we've already covered this in one of our previous tutorials, but functions, so loop and setup are also functions. You can kind of see that because they look similar to our break left wheels. The difference is that break left wheels has a parameter. So it says, I'm waiting for you to give me an integer so that I can use it later in my program, so that you can customize the time that you pause it for. Now, so this is called the parameter. This is called the functions or methods parameter. And this is called the argument. So you give an argument to method, and the argument is passed as a parameter. So that's the nomenclature for it. Okay, so now I'm going to upload. Okay, and it should be doing the exact same thing that it did before. Hopefully. Cool. So step by step, we're getting there. And so I didn't mention this from the beginning, but this has, again, been mentioned multiple times, I think, in previous programming modules, that this is not the only way to do it. This is one of many, many ways. And so I'm just giving you an idea of how you can start your robot. If you think of a better way, or a way that's more suited to what you need, then that's totally fine as well. So I'm just going to finish making all of these into methods. And you guys can follow along. And I could have had this set up before. In fact, I do have a copy. Sorry, just a second. I can't right now. Here's the pen. Sorry, guys, my little sister. None of those are sharpened.
Can I use this?
You can use here. Sorry, guys.
I'm sorry, I'm your little sister.
She's writing a test. Go, go.
Not a test, the work.
Sorry about that. Okay, so what was I saying? Okay, we're gonna keep going with this, and the reason I don't have, sorry, I was just gonna say the reason I don't, and I guess I could change it, but the reason I haven't put what I've prepared is just because I want you guys to follow along and maybe see the process, or maybe watch as I do it and see, like, see how I do it and not just the end product. So here, say 1,000 and forward left wheels. Okay, so now we have the same program for the third time, but it's written in a different way. So I hope everything seems to be fine. And I'm going to upload this program and we're going to see the same thing yet again. Although you guys could trust my word for it, but you know, oh, I was wrong. There we go. I'm sure one of you guys spotted that. I did not. Backward left. Oh, another spelling mistake. See, I shouldn't be so confident. You do that when you're programming. You're like, oh, this for sure works. And then it doesn't. Okay. So if you guys can see, all right, same old story. Great. So now we're going to do the right wheels. So I'm going to go through the same thing as I did before, hopefully a little quicker, and you guys can follow along before I introduce any new programming concepts. So, oh, here I should do, I'm just going to copy off my cheat sheet that I have, separate from you guys. Haha, I have all of them. I'm going to put that in here. And these, again, it's the same thing as with the left one, IN2, IN1. And we're going to copy all this. And then I'm going to use my, oh, so here we went through the idea of making things into methods. So here I'm going to use my truth table and break left wheels, say here, break right wheels, and we're going to change this to ENA. And I'm going to look at my chart forward. IN1 is IN2 is low and IN1 is high. I think that's right. Yes. And we go ENA high, pause. And then for backwards, we say, wait, I hope I did this right. Let me just double check the left wheels. Yeah, I did. Okay, cool. Okay, where was I? Backward, this stays backward, but this is right. Wonder if anyone's following along. So in this case, 2 is high and 1 is low, and this one is ENA. Okay, that looks like it should be good. And we're going to change all of these to right, and now we're going to see the right side do the same thing. Cool. And let's compile. Prepared for no errors. Woohoo! Okay. So now I'm going to upload. And this time we're going to see the right, oh, not yet, because I haven't turned it on, done uploading. Cool. This time we're going to see the right side move, hopefully. Forward and backward. Forward. Okay. So now we have both sides. We have our tank drive. We can control the right side and the left side independently. Hooray, that's what we wanted. We didn't want to control 4 motors. We wanted to control our 2 sides separately, and that's what we did. I'm also going to introduce, let's say if you have, I'm going to introduce a programming concept called method overloading that I don't think we covered already. We might have, but I'm going, because I watched it a while ago, I don't remember, but I'm going to cover it again if we have. So in some, sorry, go ahead, Eric. If you had
I don't think we have.
Okay, great. So in some programming languages, you see that we're using a 1,000 over and over and over again. Sometimes you're like, what if I just want my default? I use it often. I don't want to put it right here because I might not want to use it all the time, but I do use it a lot of the time or most of the time. Some languages, they have, like Python, you can say equals 1,000, and if you don't give it anything, then it'll automatically put 1,000. Fortunately, Arduino does not let us do this. To the best of my knowledge, I know the languages C and C++ that this is very similar to don't let us do that. So what we have to do instead, what it lets us do is method overloading. So where we call this method, so the idea of method overloading is that you can have a method with the same name as another method, as long as it has a different number of parameters, or different kinds of parameters. Sorry, this could be a character, and that would accept it as method overloading, as long as it's not the same function name accepting the same kind of parameters. So here I'm going to make it so that it's nothing, and I'm going to say, I'm going to call brake left wheels, and I'm going to say 1,000 here. So method overloading is not only used if you want to call the original function because you want to fill in a parameter. For example, if I want to do something completely different in here, I can definitely do something completely different. But just in this case, this is how I'm going to make sure that I have a default, I use a default parameter. It's a nice little workaround with method overloading. So I'm actually not going to put 1,000. I'm going to put 0 because sometimes we want this to happen instantaneously, and that's what we're going to want when we use it later. And we'll see why, but I'm just going to do this for all the methods that we've written so far. And again, as always, you guys can follow along. Also, I haven't asked in a while, do you guys have any questions just while I'm doing this? No. That's interesting. Okay. Don't want to make that mistake. Forward. And we're not going to use these just yet, but they're a good concept to know, and we will use them in a moment. Not right away, though. Okay, so we know how to move these sides independently. Now we want to get the car moving forward, backwards, turning right and left. So you guessed it, we're going to be writing methods for those as well. And as always, we have our handy chart that I've made so that we know how to do that. So we can take a look here. And this is something that I think you guys can guess at, but I will just show you anyway. So if you move the car, this is pretty self-explanatory. If you move the car forward, you want to move the left wheels and the right wheels forward. If you move the car backwards, you want to move the left wheels and the right wheels backwards. To turn right, you want to move the left wheels forward and the right wheels backwards. To turn left, you want to do the opposite. And to brake, you want to use both sides to brake. Okay, so we're going to make methods for each of these, and we will see how that works. Oh, that is the wrong one. Which one is it? This one. Cool. Okay, so we want to have 5 methods. Void, forward, and again we want a parameter as to how long this is going to happen. And so here we're going to say forward, right wheels. And so here, we don't want to pass it a parameter of 1,000. We don't want to say move the right wheels forward for 1 whole second and then move the left wheels forward for 1 second. We want them to move right away. So we don't want a delay. And so that's why we're using this, this overloaded function. So forward, left wheels. And then here we want to put the delay after we've given input to both of after we've written to both of those pins, then we want to put the delay so that the left and the right wheels are both moving when we do the delay. So we can say delay, pause, and then we can do the same thing with our 4 other methods. Oh boy, lots of copying and pasting here. I really, really hope someone is following along out there. Maybe not in this live chat, but eventually with the YouTube thing, because I know how annoying it is to have to pause a programming video and then start just to copy everything down. So this way you can follow along. So to turn right, we want to go backward.
Think about the opposite.
If we want to turn, let me think. If we want to turn right.
Nope, I was upside down in my brain.
Okay, then this one would be backward. And right up here, we want to brake. Brake. Okay. And oh, why didn't I just copy and paste that one? That's a good question. Okay, brake. Right wheels. Cool. Okay, so now we want to do a sequence where we move the whole car. So we want to do forward. We want to go backward. Then we want to go turn right. Turn left. And I'm just going to turn on the lights in my room so that when I put it on the ground, you guys can see what's going on. 1 second. Okay, that's better. And let's compile and then upload this. Okay, expected. What did we miss here? We missed a semicolon. See, it's good that I didn't paste this method because then I would have had to change that everywhere. Serendipity. Okay, upload. Cool, done uploading. Now let's put it on the ground and let's watch her go. So let me get positioned. We can't see it. How about now?
Yep.
Can we see it? A little. Okay.
Should be
So
good.
let's turn her on and hopefully she goes. All right. And now, before it runs into anything. Cool. So we saw how we can coordinate that sequence of movement, and it's kind of cool how you guys saw, like, from the pins themselves, we can abstract it, so we can just say go forward, go backward, turn right, turn left. Now, I don't know if you guys noticed when it ran, in between movements, there was like kind of a choppiness to it. Like if you have to brake all of a sudden, and then the car, you know, kind of skids a little bit forward. When you turn, the inertia like brings it a little bit further than we want it to go. It's not very smooth motion. And we've covered kind of smooth controls, I think, in one of the Arduinos with the servo motors. Yeah, I don't remember who covered it, but I think it was one of the Arduinos. And so now we're kind of going to apply the same principle to this in this case. So we want to come up with a method that's called speed up. And before we do that, I'm going to, I guess, go a little bit over conceptually what we're going to be doing. This is the last section, so just hang on. So I'm not sure if this has been covered before, but in when we write to pins, so far it has been high or low, and we've been using the method digital write. Now we can use something called analog write, where we give it a value not 1 and 0, but between 0 and 255. And so in this case, we can see the difference between an analog and a digital signal. A digital signal is either high or low. There's no steps in between in here. An analog signal, on the other hand, is continuous. And if you guys have taken like high school level mathematics, you can think of this as like a sine curve, and this is more not a piecewise function because this doesn't pass the vertical line test. But you understand what I'm saying. It goes between two different values, and there's really no values in between. And so the way that we're going to do this, I said continuous, but then I also said between 0 and 255. We do our best to approximate continuity. It's a 0 to 255 is a lot more like smooth than 0 to 1, obviously. So while we don't have perfect, like we don't go in, as we mentioned, like floats are really computationally intensive, but 0 to 255 is enough that with the human eye, it's smooth enough. So that's what we're trying to get to. So we're gonna make where was I? Car moves, not here. Okay, cool. So we're gonna make two methods, one called speed up and one called slow down. So void. And again, you can structure your code in a different way. This is just how I have chosen to structure it and just give you a baseline. So we're gonna make the method speed up. And you guys, I think, have covered for loops, so I'm not gonna go too much in that, but yeah, so I'm just gonna go ahead and write it for, and so a for loop, I guess I'll go through it a little bit. A for loop is a piece of code that can, you can increment or decrement a value, and based on that value, it'll continue until the statement in the middle is untrue. So I'm just gonna say speed up, you'll see in a second, I is less than or equal to 255 plus I. And here what we're going to do is we're going to say analog write ENA, ENB, I, and then analog write ENA, I. So what we're saying here is ENA before, ENA and ENB earlier, we used to say listen to IN, listen to IN3, listen to IN4. Now, since it's no longer 0 or 1, it gives the motor driver gives power in on a continuous basis to the to the motors. So it's no longer either give it all the power or give it no power. Now we say, okay, make it a little bit, we're incrementally increasing the power that we're providing to these motors. And so I'm just going to do the same thing for slow down. If you guys have any questions, you can ask right now. If not, forever hold your peace. Or, you know, you can always just ask in the Discord chat. We encourage that. So you guys, this is just a little thing, but you guys, I'm sure, have seen the increment and decrement operators. Usually this, you guys, what's more commonly used is the postfix operator. I, out of habit, use the prefix operator, which uses increment. So the difference between these two is that this increments it and then gives you the value. So if you were to say, maybe this is a tangent that is a little bit too detailed, but I'm going to go at it anyway. It's really interesting. So if I were to say, I'm not actually going to show it to you, but if I were to say, for example, print or serial, okay, you know what? I will put it in the main method and we will see. Serial dot write. I wish I was connected to the thing that I could show you guys. So if we have a variable, we say int I equals 4 and int j equals 4. And we were to say serial write, this is I, and we give it serial write plus plus I. What this will print is this will increment I and then give you the value. So it will print 5. And then if we do the same thing for J, this is a really unnecessary tangent, but kind of unplanned, but it's interesting. And if we say this is J, but we put it afterwards, then this will say this is J4. So this will say this is I5, and this will say this is J4. Let me see if I can actually just see it from compiling. Where's my serial monitor? Oh, it doesn't upload for some reason.
You'd have to have your car plugged in.
Yeah, okay.
And then deploy the code. But if you leave it powered off USB, it'll work. You might need to comment out your drive, because if you only power off USB, you won't like that. It's not enough power.
Okay, cool. Hopefully it doesn't. Okay, let's see. Not show me anything here. Oh, what is it doing here?
Have you uploaded your code yet?
Strange. Oh, I have not. No, that makes sense. How's it? Okay, serial monitor. Maybe this is an unnecessary tangent. Why can't I see it? Oh, because I closed it. Maybe I closed the tab. Yeah, I did. Okay, let's put a big delay here, actually. Delay. So that we can actually see it. I guess I could have just put it in the setup. Anyway. Okay, why is it not printing? This is I. Why is it not printing? That's very strange.
I think that syntax doesn't work on those like that. You might need to just do 2 serial writes.
You have to convert it to a string.
Or just do 2 serial writes, like just put a second serial write for I and J.
Okay. I don't know why. If this doesn't work, we'll scrap this idea, because this is
and trust you that
too long of a thing.
One will print as 4, one will print as 5, and they will both end up as 5 at the very next line.
Yeah. So we'll try this one, and if not, it's just interesting to know. I didn't know that for a very long time. I didn't know the difference.
I do know on some
And
computers doing
open.
++I is actually faster than doing I++.
Okay, so for some reason it's not showing it. It doesn't work. You're gonna have to trust me. This is not the purpose of this exercise. Okay, just have. Yeah. So in this case, it doesn't really make a difference because we're just using it right here. But it's just interesting to note. Okay, so we have this speed up function that reads progressively more, that makes gives progressively more power to these inputs ENA and ENB, and this one is decrements. So when we want to put it whenever we have a motion. So we want to go forward, right wheel, forward, left wheel, and then we want to speed up. Because, okay, and then instead of in these, here's what I was going to say. Instead of in these methods, instead of writing high, we can just remove that, and we can count on the speed up function to write to these for us. So we're just going to remove all of those. Those choppy motions, and we're gonna speed up on the level of our forward functions. So we're gonna say speed up. So we give it the value, and then we change the enabling, and then we have the delay, and then we slow down. I clicked copy. Great. Okay. And so now we want to upload this. Well, first let's verify it because it's a decent change. Done compiling. Let's upload, and let's see if we can see if the motions are less choppy. I'm not sure if you can see it with your naked eye. However, it should. When I tried it, you could see it. So let me just get everything set up, and hopefully, maybe you guys can't see it through the video because the video might already be choppy in and of itself. Can you guys see anything? No. Okay, hold on.
A little further out.
All right, well, here. All right, the motion is definitely, you guys definitely can't see the difference in the motion just because of the video, but you guys are just gonna have to take my word for that one as well. And, this is a good opportunity for you guys to try it yourselves. So, win-win. Okay, so that was the basics on how to make the car move. We took it from a very low level of just the ports themselves to being able to give it a sequence of movements. Does anyone have any questions? I'm just gonna stop it. Does anyone have any questions? Seems like no. Okay, so there's two things. Oh, you're welcome, Connor. There's two things that I want you guys to think about going forward. You don't have to have like an answer to this or anything, but just to think about how we're gonna do this going on. How do we, instead of just programming right into the robot, move forward however many seconds, move backward however many or milliseconds or all that, how we're going to program into the robot that to receive input. And you guys probably won't know the answer to this right away, but just think about that that's an extra step that we have to do. And another step that's quite a bit trickier is, instead of giving it, like, to us, we don't know what go forward however many seconds means. Well, it depends on the speed, right? You wanna program your robot and depending on the speed and the distance and things like that. Going forward, however many seconds is not a very useful tool. And also, think about you might think, okay, well, if I know the speed and I know how many seconds I'm going, then I know the distance. But the problem is that the speed might not be constant. The speed, if you're on a different surface, your wheels might slide a little bit more, and the speed might not be constant. So you can't be as precise. So if you guys want to, some of you guys who've programmed FRC robots might already know how you control for this. But if you guys want to think about the ways that you can make it a little bit easier to program, and I think we will touch upon that in a later workshop at some point. Okay, that is all. Again, any questions? No? Cool. All right, well, I think I'm done.
All right,
Have a
thank you for
good
that.
Thursday.
I'll send you guys the link for the survey if you want to fill any of that out. Yeah, thanks, Roxy. That was great. Definitely one of our longer workshops. We kind of expected that. Maybe you guys didn't, sorry. But hopefully it was useful information. This really can be kind of where you can win on games, is having a good drivetrain. I know a lot of you have done FLL before, and so you've done some of that stuff, and you've probably played with encoders, which is a bit of a sneak peek answer to what Roxy was alluding to, where you can measure your distance. But yeah, we'll definitely have a lot more to come on these concepts. And if you want to suggest anything or have a question on where do we go from here, feel free to put it in Discord. And I think that's about it. So if you have any further questions, you want to stick around for another minute or two, we can do that. But in the meantime, good night, everybody, and thanks for coming out.
Bye, guys.